So welcome to the first recording, which is devoted to the introduction of statistical program called fully IBM SPSS Statistics. This is the first recording which will introduce the program and also you will recognize how you can open data file. Next recordings then will continue to show some basic data analytics steps such as data preparation and also data analysis. So let's start with some brief introduction of the program itself, and of course I will show you also some practical examples. Um, you can also find below this recording on YouTube the link to Google Disk, where you can find this presentation as well as data file, which is used for practical examples. So, first of all, some brief information about the program itself. The history of the program is quite long. Platform which was originally named SPSS, and we will also use this shortage, started in 1968. So you can imagine that this program is developing for 50 years. And the original name SPSS stands for Statistical Package for Social Sciences. So it means that it was mainly designed for social science research. And currently also, it is still very often used for data analysis for data which were collected by social science researchers. Doesn't matter whether it is applied research, such as market research or public opinion research, or whether it is applied by academics at universities and other scientific departments. The big advantage of this program is that usually if you find professionally collected data, usually you can use something what is called data archives. So these data are very often provided in the format which is ending by the extension SAV. And SAV extension is native format which is created by SPSS. And as you will recognize, this format is very, very nice to use, as it includes not only rough data, but also many information related to these data. And the next advantage, at least if you use menu in IBM SPSS Statistics, is very easy to use program. And I would say it is a very user-friendly program. If you switch to another mode, which is also possible to use in IBM SPSS Statistics, so it means programming by something that's called syntax, it could be maybe slightly more complicated, but comparable to other statistical programs. So let's go to a brief schedule. And first steps included in this recording, first of all, it will be short excursus about variables and their types. Then we will open data file, and we will check the data, and then we will recognize that usually for individual variables, so it means information we are collecting in data file, we can change something what is called variable properties. We will discuss about names, labels, value labels, missing values, and we will show also some first steps in basic description of data. In the next recordings, you can find more information about data transformations, about descriptive statistics, and also about common statistical tests. And now, as I promised, a short excursus about variables and their types. It is necessary to understand to the meaning of the key word for data analysis or statistics, which is called variable. And also, you must differentiate between different types of variables, as usually different statistical procedures, different types of data analysis must be applied properly according to types of variables that are included in your data file. First of all, we will discuss the topic, what is variable? So if something has at least two different values in your data file, it's variable. Let's imagine that you are collecting data in some group and you have at least some male and female respondent in this group. So the variable which will be trying to catch if you are male or female, let's call this variable sex, will be variable as it is not the same for all units. If, just opposite, you will collect the data and, for example, you will get all female respondents, so then sex is not variable, but it is constant. And we must inform that if you have constant, it is not interesting for statistical data analysis. So mainly statistics is the science or practical activity related to variables. But not all variables are the same. That's why we must distinguish at least three types of variables. We will use classical description. So it means we will call the first type as nominal, second type as ordinal, and the third one is cardinal. We will discuss theoretical about these types, and also we will provide some examples. So first of all, theoretical description of nominal variable. It is, as the name itself provides some recommendation, based on some individual names. Nomen from Latin is the name in English. So it means these variables are usually expressed by different names. And from a statistical point of view, it is necessary to say that if you have two different options of nominal variable, you can say they are different, but it's not possible to make any rankings. So it means that no one option is bigger than another one. And it is also impossible to compute something like difference, sums, or other numerical computations based on these nominal variables. So let's have example. And once again, we can switch back to the variable which is sex. So let's imagine you provide only two options. So it means male or female. And you can only inform that if you have male, it is another option than female. But you cannot say that male is more than female or just opposite. And it is impossible to compute any difference, etc., etc. For practical reasons, usually in data, so it means also in SPSS, you will use some coding. So for example, you will replace by code 1 option female. And you can, for example, decide that for code 2, you will use male option. So it means that in your data, it will be only codes 1 and 2 instead of typing female and male. It saves time and also it saves the place on your disk or memory of your computer. So let's go to ordinal variables. Ordinal variables are usually also expressed by names, but it is possible for options for ordinal variable to make some ordering. So it means to say that something is the lowest, something is maybe in the middle, something is the highest option. Let's start once again with classical example, and it could be the level of the achieved education. So somebody can achieve primary, somebody can achieve secondary, and maybe that somebody can achieve tertiary education. So tertiary is, for example, different than secondary or primary. So this is the property for nominal variable. But you can also make ordering. Primary is the lowest, secondary is in the middle, and tertiary. And of course, you can have more than three options for the variables. And once again, usually in social sciences, you use some artificial codes. So 1 stands for primary, 2 for secondary, and 3 for tertiary. But be careful, if you have these codes, still these options are primary, secondary, and tertiary, and no computations, such as computing difference, sums, etc., are possible to use. Technically, it is possible to use these computations, but from statistical point of view, it would be total nonsense. So we know about nominal variables and ordinal. These two sometimes are together called as the categorical variables, as it means they have only different categories which are described by some names, and only for technical reasons we use these codes for data analysis. Cardinal variables are totally different from previous two types. So it means here we have real numbers. So it means it is not necessary to assign some artificial codes. It is not necessary also to discuss that we can only make ordering or no ordering is possible. So it means that for these variables, we can apply mathematical operations such as the difference, we can compute sums, etc., etc. So these are pure numbers. Let's have a very simple example. In social sciences, for example, we are asking about the age of the respondent. So it means if you have somebody who is, for example, 20 years old and 40 years old, we can, according to the property of nominal variables, say they are not of the same age. 20 is not the same as 40. We can also use the property from ordinal variables. So 20 is less than 40, or just opposite 40 more than 20. But we can also make subtraction. So 40 minus 20 is equal to 20. So it means there is 20 years difference. And we can also compute sums, etc. And that's advantages for statistics. For example, I guess you know that something that is called arithmetic mean, sometimes average we call it, is simply computed as sum of all values divided by the number of units. So for cardinal variable, that's not a problem to compute average or arithmetic mean. But for ordinal and nominal, from statistical point of view, it will be total nonsense. We will discuss more about descriptive statistics for nominal, ordinal, and also cardinal variables in the next recording. So that's it, and that's about variables. And now we can introduce the program itself, open the program, open data, and discuss about variable properties. So first of all, we will open the program itself. I have it opened on my computer previously. So here it is, how it looks like for the first inside. So here you have some blank table. And the program is expecting that you will open some data file or you will enter your own data. I will not show you in this recording how to enter data manually here. It will be also included in some later recordings, but here I will open data which are prepared for us. Data file is called, and once again, it is available on Google Disk, and the link is under the recording. And this data file is called UVS 2017 CZ short SAV. UVS stands for European Value Study, which is International Sociological Survey, which is held usually every 10th year. The last wave was administered in 2017. CZ means that these data are only for Czech people. And short means that it is only a small piece of original data set. So it means that I selected only some variables included in this file. To open data file in IBM SPSS Statistics, you can use two options. First one, you can double click here into the file. Second one option is you can use this opening folder or file, open data. And then you can find your data. Both of these options will be the same. I will click here, and here it is how it looks like. First of all, you should understand that these data use some technical names, V9, V10, V11, V12 style. It is quite classical in international social surveys. So UVS is not the exception. But of course, you would be interested. What is the meaning of V9, V2, V11, etc.? First of all, we will give you some more idea about meaning of rows and columns in this shape, which is called usually data matrix. So it means that my data are present here. So first of all, it is good to say that these individual rows are usually called as cases. In this case, so it means for UVS, cases are individual people, individual respondents that were answering the questions in UVS study. So for example, if you go down and check how many people answered for the questionnaire in the Czech Republic, so it was 1811. So we call this number as sample size. Usually use also small n symbol for sample size in social sciences or general in statistics. So once again, cases. Sometimes cases could be different from individual people. For example, that your research is devoted to description of some families. So research unit or case could be the family. Maybe that you're interested in business and you would like to inquire individual companies. So companies could be individual rows or cases for your data analysis. So this is about rows or cases. And individual columns are individual variables. So it means they are usually based in social science research on questions that are behind the scene, and answers to these questions are created in these columns or variables. And now it's good to understand what is the meaning of these individual columns. So it means these individual variables. You can find that here we have something like approximately 30 columns. And if you like to inquire on the meaning of these columns, you have two options. You can go to original questionnaire. You can find original questionnaire for UVS study on web pages of this survey. But if it is SPSS data file and already prepared by professionals, so you can also click here on the down part to this variable view option, and you can find more information what is behind the scene, as here you have something what we call variable properties. So you can skip to variable properties, and here we have the most important variable properties we will try to describe here on this data file. So first of all, the first something what is called name is called maybe sometimes also technical name, and it is usually some short abbreviation with no intrinsic meaning. So it means that every individual variable must have some unique name. It is also important to inform you that SPSS is not differentiating small and big letters, so it is not case sensitive. Most statistical packages differentiate between big and small letters, so be careful that SPSS is not differentiating. So it means V9 in small or big letters will be the same variable for SPSS. So we have here technical name. But if you would like to understand what is behind the scene, it is good to find the column which is called label, or it could be maybe ideal to call it variable label. As it is description, what is the meaning of the variable, it is usually the shortage of original question from the questioner, at least in social sciences. I will make it bigger for you to understand what is the meaning of individual variables. So for example, V9 was the question like, do you belong to religious organization? An original question in the questionnaire was called Q4A. The second variable is answering the question if you belong to cultural activities, etc., etc. And if you go from V9 to V19, so it is the set of 11 different organizations to which you can belong. The last one is other groups. I will mention only the next one variable here for this first introduction. And for example, VS39 is the level of the satisfaction with your life. So that's it. And it is the tool by which you can find the meaning of individual variables. So for all variables, there is some meaning. You can also find that in the second column is something what is called type of the variable. We discuss about types of variables, and we discuss that we have nominal, ordinal, or cardinal. But here, it is not nominal, ordinal, cardinal. These properties are described in this column, which is called the measure, nearly at the end of these variable properties. So here, you should define properly whether your variable is nominal, ordinal, or cardinal. SPSS call cardinal variables as scale, and you can find that also here we have different pictures for these different types. So it means for different variables. So here we have type of the variable in the technical sense of the meaning. And if it is written here that all of these variables are numeric, So it means that my data here are included as numbers. I have also another options. I can, for example, decide that I will not use numbers, but for example, for the question with answers yes or no, I will be typing yes or no. But once again, usually in social science research, we use some artificial codes instead of original names, and that's why here we have all data as numeric. And mostly in social science research, we prefer this numeric types of variables. If you would like to change it, it is enough to click here on the left side of this numeric expression, and you can, for example, find here string, which is text formatted data. You can, for example, use some date formats. There are a lot of these. And for example, you can use also some currency such as dollar or other currencies formatting. But once again, mostly we prefer numeric, so that's why it is included here. Please also, it's good to mention that here you have how many numbers are included and how many decimals. All my data are formatted as maximum three digits and zero decimals, but you can arrange it according to your wishes. Maybe that even more important that to understand what is the meaning of individual variables, original questions, is also to know what are possible answers. So here in the column which is called values, or in another words, it would be value label, you can find a description of possible answers, for example, to the question if you belong to a religious organization. So once again, you can click here and you will open the list of all individual labels. So you can find there is some called -10, multiple answers, no follow-up, -9, -8, blah, blah, blah. So these answers up to -1 are not very important for us. But if you mention that you belong to the organization, you will be coded as 1. And if you didn't mention that you are belonging to a religious organization, you will find the code 2 in my data. So once again, if I go back to data view, for example, for the first respondents, you can find 22222. So it means they do not belong to religious organization. If you go, for example, to organizations related to cultural activities, for example, for the first respondent, there is yes, I do belong. So that's the meaning of these individual codes. So once again, for all variables here, you have some explanation what is behind the scene. So it means what is the meaning of all individual answers. So that's it. And it is how you can find it. There is also another option. You can go to this icon, which is in the middle, 3 called stripe and column. And it is very quick introduction to variable properties. So you can here only find the information. It is impossible to change it here. If you go back to variable view, here you can check information, but if you like, also you can change it. For example, you can cancel it, you can add more labels, etc., etc., and you will find more in the next recordings. So that's basic information about variable properties. But last one property, which is also necessary to discuss, is still waiting for the introduction. And it is the discussion about missing values and missing value definitions. First of all, I will once again go back to my data view. And if you go to the data matrix, sometimes it can happen, I'm not sure if I will find this point in my data, that some information is missing. There will be only blank space in some packages such as SPSS. There will be only dot in my data matrix, but I guess here it's not present. But still, we have some answers that are not real answers. And we would maybe, for analytical reasons, to say to SPSS, please do not include these answers into my computations. I guess that, for example, for V9 here, for the respondent number 9, there is -2. If I go back to variable view description, I can find that -2 means there is no answer. So if I would provide, for example, frequency table for V9, I would like to maybe exclude these -2 and also maybe other codes such as -10, -9, -8, -5, etc., from this frequency table. Let's see how we can provide frequency table in SPSS. I will only close the second blank data. And if you like to go to this option, so we can go to the menu and check Analyze, Descriptive Statistics, and Frequencies. So let's follow these steps. So Analyze, Descriptive Statistics, and Frequencies. This is the first dialog in SPSS, maybe in your life. And the style how SPSS works with this dialog is very, very simple. So first of all, on the left side, you have all variables that are available to the current procedure. And by moving by this arrow, you can say for which variable you would like to make some computations or another procedures. So for example, if you like to take the first one, P9, if you belong to a religious organization, let's try to move it. And then you can click simply into OK, and SPSS will open a new one window, which is called output window. And there would be, as an output, frequency table for this variable about belonging to a religious organization. So here it is. And here you have 263 people with no answer. 21 do not know whether they belong or not. And 182 mentioned they are belonging. And 1,345 discussed they are not belonging to a religious organization. And for analytical reasons, maybe we would like to avoid to no answer and don't know answer to have valid person computed only for those who mentioned or didn't mention the belonging to a religious organization. And this is how it works to avoid to some answers to define missing values. So you would go into the column, which is called simply missing, to the variable V9 for this first case, and I would go to this dialog. So by default, there was written no missing values are defined. So currently, we will be providing something what is called user missing values. So we will decide as users of SPSS that some values will be omitted. Once again, if you do not remember which values should be omitted, you can go back to the description of individual value labels. And once again, -10, -9, -8, up to -1 may be necessary to define as missing values. In real data, we have only -2 and -1 according to frequency table. So maybe only -2 and -1 should be defined as missing values, but we will take all of these for simplicity. So if you go back to missing, I will go to the last one option, which is saying you can define range. So it means from some number to another number, plus one discrete missing value. So if I type that from -2, then, sorry for that, till -1, I will exclude all these values from the computation. So for valid percentages, these don't know, no answer, etc., will not be computed into the final result. So that's enough. No other option is necessary to add, and click into OK. So here you can find missing values are properly defined. If you would like to check it by this variable viewer, so you can also find this V9 and here missing values from -10 till -1. And if you go back to analyze descriptive statistics and frequencies, you can check that SPSS really will not use no answer and do not know options for the computation of valid percentages. If you do not like to, once again, follow the long way, it means analyze descriptive statistics, frequencies, you can use this first icon, which is recalling recently used dialogues. So if you open it and go to frequencies, which is the last one, not only you can go very quickly to the last procedures, but it is also defined as it was in the last step. So once again, belonging to religious organization is already here selected. So it is enough only to click into OK. And here it is. Mentioned and not mentioned to belong to religious organization are valid options. Missing options is no answer and do not know. So for valid percentages and also for cumulative percentages, but they are not useful here, it is based only on these valid answers mentioned and not mentioned, and no answer and do not know are ignored for these computations. So that's the first usage of missing values. I will give you also some easy technical trick how we can use this definition of missing values for other variables. So for example, here for V9 up to V19, as it is all about belonging to different organizations, and it has the same coding system from -10 to -1. These answers are not very useful, and 1 means mentioned, 2 means didn't mention. So it would be nice for all of these to define the same set of missing values. Of course, you can click here, 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 and make it once again 10 times. But very easy is to use Control and C, so it means copy, and Control and V, paste option. So if you click here and to say Control and C, and then go down and select all of these and Control and V, pasting. So for all of these variables, the same set of missing values is properly defined. Of course, it's not necessary, and it would be also maybe a mistake, to copy to another variables. Maybe they have another coding scheme, and maybe they have another options. We can check it, for example, but here it seems that also here, from -10 till -1 should be defined as missing values. Also, we can check another options, and it seems that for all variables here in my data set, it will be possible to use the same definition of missing values. So only once it will be defined, and for all the rest, it will be copied. So that's very easy style, and it is how it works in SPSS if you define your user missing values. So thanks for your attention for the first recording, and you can follow, of course, the next recordings devoted to the next analytical steps.